So we're starting on chapter 2. Well, let's read through the notes and then we'll do some examples. Okay, so this is section 2.1 of relations and functions. So most of it should be reviewed for you guys. A relation is a set of ordered pairs. It can be represented as a list, as points on a graph, in a table, or as a mapping. The x values, the first number in the ordered pair, are the values in the domain. The y values, the second number in the ordered pair, are the values for the range. If every value in the domain is paired with exactly one value from the range, the relation is called a function. In other words, the x values cannot be repeated for the relation to be a function. If the relation is pictured as a graph, the vertical line test will indicate if it is a function. Do you guys remember the vertical line test? Okay, well, we'll go over it so that refresh your memory. I think when you see it, you'll remember. If any vertical line contains two or more points, then the vertical line test fails and the relation is not a function. The symbol f of x, that's not f times x. That's read f of x. That's function notation. F of x, it means the value of the function at that particular x value. It's the same as a y. So f of x is another way to write y. They're interchangeable when you're writing equations. All right, so let's look at this first example. Okay, before we do that, let's look at page 61 real quick. There's something I want to point out on that page. It talks about in the key concept table that they have on page 61, talks about one-to-one function. Each element of the domain pairs to exactly one unique element of the range. And you can see that from the domain to the range, they're all paired just to one element, except there's an extra range that's left over, which you're not usually going to see, right? Because in algebra, you always have x's and y's together. So it's really not going to happen that way. Then you have an onto function where each element of the range corresponds to an element of the domain. So you have one element of the range being used twice, but everything is being used, there's nothing left over. And then you have both one-to-one and onto functions. Each element of the domain is paired to exactly one element of the range. Each element of the range corresponds to a unique element of the domain. So in this chapter, it's either going to be both one-to-one and onto, or it's going to be neither. One or the other. You're not going to have one-to-one without it being onto. Okay, so just for future reference, I wanted to point that out to you. So on number 1, they give you a set of points. -4, 3, -1, -2, 0, -4, 2, 3, and 3, -3. And they want you to write the domain and the range and then tell if it's a function. So your domain value, I'm just going to denote that with a capital D. So you don't have to write out domain and range every time. You can just use a capital D for domain, capital R for range. Okay, so your domain is just all of the x values in your points. So the way that you write it out is you use the squiggly bracket, just like they present it to you. And we're just going to list all of the x values, -4, -1, 0, 2, and 3. And you could just write them in the order of the ordered pairs. You don't have to like try to organize them in any certain way. If you do, that's fine. If you don't, that's okay. All right, so then your ranges, your range numbers are just your y values. So I'm going to just list those out. I have 3, -2, -4, and then this fourth y is a +3 again. You don't have to list it twice. It's already being listed, so we don't have to write it again. I'm just going to end with -3, and that's my range. And then it's saying, tell if the relation is a function. And none of my x values are being used more than once, so this is a function. Okay, so if we look on your notes, here's number 1, right? And then this is number 3. They're just presenting points in a different way. They're graphing it instead of listing it out for you. Okay, so we're going to skip this number 3, but we're going to go down to this this graph, and we're going to make a table, graph the points, and draw a mapping for number 1. We're going to do number 1 here. So when you make a table of values, it's where you have your X and your Y, and you make that T table. And I'm just going to list my points from the original problem here. So I have -4, 3, -1, -2, 0, -4, 2, 3, and 3, -3. So this is making a table. That's all you have to do to make a table. And now I'm going to graph each point. Alright, here's -4, 3, -1, -2, 0, -4, 2, 3, and 3, -3. Alright, so here are my points. Now when you're given just a set of points, you do not draw a line and connect them. This is your graph. It's just a set of points. So this is called a discrete relation. Okay, and that's an important word. The points are not connected, it's just a set of points. Any questions? Okay, then the last thing they want you to do is to draw a mapping. So I'm going to list my domain vertically and my range vertically. I'm just going to use what I have written up here. For my domain, I have -4, -1, 0, 2, and 3. And then my range is 3, -2, -4, -3. And then your mapping is just you're connecting the 2 points that go together. So my first point is -4, 3. So I'm just going to draw kind of a long arrow from my x value to the y value. Then -1, -2, 0, -4, 2, +3. So this one's going to go up a little ways. And 3, -3. And that's a mapping. Any questions? Okay, you guys do number 2. And I'll do it up here and we'll see what everybody gets. So you want to state the domain and range and if it's a function, and then go down to the other graph that they have set up for you and make a table, graph it, and a mapping. Okay, so you guys do it at your desk, I'll do it up here. Is everybody finished with number 1? Okay, so my domain is -3, 0, and 2. Range is 1, 2, and 4. And it's not a function because your x value is being repeated. That -3 is being repeated. Okay, so let's do the vertical line test for this one. And you can do it even if it's just a set of points. So you take a pencil or a pen or something and you place it vertically on your graph, and you're just going to move across the graph vertically, and the pen should only intersect your points or your graph one at a time, at one place at a time. So here it's only crossing that one point. Here it's only crossing one point. But when I get over here, then I have 2 points that it's crossing. And so it fails the vertical line test at that time. And it's not a function. Any questions? Okay. Let's move on down to number 5. We're going to graph the relation represented by y equals 2x plus 1. Get the domain, the range, and tell if the relation is a function. So first of all, looking at number 2 and number 5, what is the main difference between those two problems? Does anybody want to be brave and take a guess? What's the difference? This one is what, and that one is what? It's not a trick question. Somebody said something I mentioned.
And the other ones are ordered pairs.
Okay, this one is a bunch of ordered pairs, and this one is a line. It's an actual equation. So when you graph this one, you are going to have a shape that you draw. These, you just have points. This is the discrete relation. This is going to be an actual graph, a line, and this is a continuous function, or a continuous relation. So you need to be able to tell the difference between continuous and discrete. If it's an equation, more than likely it's going to be continuous. If it's just a set of points, it's discrete. Okay, so the first thing we're going to do is graph this. There are lots of different ways that you can graph a line. So go ahead and graph that line however you want to. You can use the slope and the y-intercept. You can plot points, whatever you want to do, but we're graphing a line. And everybody should come up with the same one, so. Okay, so here's my line. And if I use the vertical line test to tell if it's a function or not, I'm just going to move this pen across the graph vertically, and it's only intersecting the graph at one point at a time. Okay, so it is a function. So you say, yes, it is a function. And then they want me to state the domain and range. And the domain and range is a lot different from what we just did, because with a set of points, your domain is just whatever x's they give you, the range is whatever y's they give you. But when it's an actual graph, you have to think of it differently. So your domain is still whatever your x's are, okay? But in this graph, your x's are on this horizontal line. It goes left and right. So we got to think about any restrictions on the x. Is there anything that x can't be? Is there any number? Can I put any value in for that x that I want to, or is there something that I cannot use? What? Is there a restriction?
No.
No. I can use any number I want to for x. I can put 1,000,000 in there for x, and it would still be fine. So my domain is all real numbers. And I just use a double bar on the r. It's a little shorthand. for all real numbers. And then the same thing applies to the range, except now you're talking about the y values. So y's are up and down. Okay, is there anything that I cannot use for y? Is there a restriction on my y's? No, there's not a restriction on the y's either. This line is going down infinitely and it's going up infinitely. So that's covering all my values. So that's going to be all real numbers again. Okay, any questions? Okay, let's look at number 6. Number 6 is different from number 5 in a couple of ways. First of all, number 5 is a line. Everything's to the first power. Number 6, you have y to the second power. It's not to the first power anymore. So what kind of shape do you think this is going to be? You talked about this the last part of Algebra 1. And it starts with a P. It rhymes with parabola. Parabola, very good, that's right. A squared term is going to make it into the shape of a parabola. Okay, so that's one difference. Another difference is that in number 5, your x variable is independent, y is dependent, okay? Which one's independent here? X is not independent. Y is independent. I can put any value I want in there for y, and x is the dependent one. Okay, so there's a trick whenever you graph these. So you need to pay attention to this because you're going to have to do it in your assignment. Okay, whenever you have something squared like this, the values that I choose for y need to include negative and positive values. So good points to start with, and you might have to vary from on some graphs, but this is a good one to start with, would be -1, 0, and 1. As we get into doing these graphs a little bit more, it's going to change a little bit, but you need positive and negative values. Okay, so I'm going to substitute -1 in for the y, and I'm going to put parentheses the -1 because I want to remember that when I square it, I have to square the negative and the 1. So what is my x value going to be? -1 squared is 1 minus 2, -1. So x is -1. Okay. Going to be -2. And when y is +1, what's x going to be? -1 again, right? So I can see that my values are repeating. So what does that mean? It's not a function. So I can answer that question right now without of when it fails a vertical line test. Okay, so I'm going to graph it. Now remember, we've already here. I need to make it a curve, right? Okay, so I got -1, -1. So now I'm going to connect those points. And I have a happens when you see the x instead of y equals. It changes which way it faces. All right, so doing the vertical is hitting the graph in more than one place at a time. So this is a good illustration of when it's not. The other thing, determine the domain and the range. So I'm looking left and right. Is there anything that my x won't be? Is there a restriction on? It's not going to go past this point. -2. So your x values have to be bigger or equal to negative.
determine which one right now, but greater than or equal to negative 2. The R value. So remember that your parabola is y. And that parabola is actually wider and it's going to be all real. Okay. Let's go down to
about this one. And then I'll sit there.